So last week, we spent a lot of time talking about textual analysis, and this part is related to the image segmentation part after edge detection. Specifically, we went over color blobbing, which I mentioned in the last video, and color blobbing is essentially color blobbing is a way in which you can segment different parts of the image. Color blobbing takes in a black and white image, which we call a binary image, and it goes through every single pixel to find the blobs, the white blobs, in the black image, and it colors that blob a color. Now, according to the four-color theorem, you can color all the different regions on a map with four colors. So similarly, in blob coloring, you can color all the blobs with just four colors. Now, effectively, you can label every single blob with a segment, and that's how you would get the computer to recognize different sections of an image. So that, I believe I talked about in blob coloring. Now, something else that went right after is using statistical methods for analyzing textures in the image. So the first method that we talked about is using a co-occurrence matrix. A co-occurrence matrix is simply a matrix that talks about the co-occurrence of two pixels and the number of times those two pixels occurred in an image. So the co-occurrence matrix looks at the difference between the two pixels. So we have pixel I, and we have pixel j, and it says how many times these two different pixels occurred. So suppose I have an image with gray length, not gray length, the number of gray colorings to be 2, for example, 0, 1, 2. And I have 0, 1, 2. And this will tell me, suppose I is 0 and j is 0, so you have a pixel that's like this. Then number of times that has happened in an image, let's say none. And similarly, if an image has 1 and 0, that's 1 and 0, we can say 4 times. So this would be a co-occurrence matrix. And in class, we used 4x4. So in this case, if we normalize it, it will be out of 9. But in our class, we use 0, 1, 2, 3, then that will be out of 16. So that is a co-occurrence matrix. And based on this, we can run a lot of statistical methods to distinguish the different texture properties, so we know one texture from another. So based on this, we can do what we called image moments. Image moments for 0th order image moment. Here, the 0th order. So this is from x I goes to 0, j goes to 0. So x I j, and then we have our co-occurrence matrix here. So an image moment is essentially trying to determine different properties that an image may have. So in this case, we could have a 0th order in which these two are just 0, then we would essentially be integrating the image. So we would just find the area of the blob. If we were to have a 1st order, image, then we will be finding the center of the blob. In this case, will be called the centroid. And the second order would be finding the orientation of the image. The orientation is defined as the elongation of the blob, so where the blob is widest. So if the blob is widest on the horizontal plane, then it would be the orientation of the blob would be horizontal. If the elongation, the longest part of the blob is vertical, then you would say this blob is vertical. And that the second order moment will be able to tell us that. Next, I'll be talking about energy, entropy, contrast, and homogenization.